Public Exam Review, Unit 5, Chapter 5, Trigonometric Functions and Graphs. In this presentation, we will review transformations of the sine and cosine functions in terms of y equals a times the sine or cosine of b times x minus c plus d. Here we will focus on graphing and transforming sinusoidal functions of the form y equals a times the sine or cosine of b times x minus c plus d. And we will look at the effect that each of these parameters, a, b, c, and d, has on the transformation. We will also identify the domain, range, phase shift, period, amplitude, and vertical displacement of sinusoidal functions. In the first example, which transformations of y equals the cosine of theta will produce the graph of y equals a negative 2/3 times the cosine of 4 theta minus pi? We need to rearrange the equation so that we can identify the horizontal stretch as well as the horizontal translation. So we will rewrite the equation as y equals a negative 2/3 multiplied by the cosine of, we'll take 4 out as a common factor, outside of theta minus pi over 4. Let's check that. 4 times theta is 4 theta, and 4 times a minus pi over 4 is a minus pi. The negative in front of the 2/3 represents a vertical reflection in the x-axis. The 2/3 refers to a vertical stretch equal to 2/3. We need to use the reciprocal of 4 to determine the horizontal stretch equal to 1/4, and then the pi over 4 at the end represents a horizontal translation equal to pi over 4 units to the right. This information corresponds with, we're looking for a reflection in the x-axis, which is common to all 4 choices. Vertical stretch equal to 2/3, so that eliminates C and D as multiple choice possibilities. So then a horizontal stretch equal to 1/4 and a horizontal translation of pi over 4 units to the right corresponds with A as the multiple choice item. In example 2, what is the vertical displacement of the graph 1/2 y equals the sine of 3 times x plus pi over 6 plus 1 as a transformation of y equals the sine of x? In this equation, we need to rearrange the terms again, but we need to multiply both sides of the equation by 2. When we do that, we will have, just let me write it down. We have to, when you multiply 2 times 1/2 y, it results in just y. But then the 2 has to be multiplied by the sine of the angle part. So you get 2 sine of 3 times x plus pi over 6. And the tricky part of this question is the 2 also needs to be multiplied by that 1. So you have a plus 2 at the end. The plus 2 at the end gives us our value for D. So D is equal to 2, which represents the vertical displacement of 2 units upward, because the value of 2 is positive. That will also give you the equation of the sinusoidal axis for this graph, which will go through y equals 2. So the correct answer is the vertical displacement of 2 units upward. In example 3, which represents the sinusoidal function y equals the negative cosine of 2 times x plus pi over 3 minus 4. The first thing that I look at here for this one is the value of D. D is equal to a negative 4, which tells us that the sinusoidal axis passes through y equals a -4. That eliminates B and D as multiple choice items because the sinusoidal axis for both of these graphs passes through y equals a +4. The next thing that I noticed there is the negative in front of the cosine. That negative is tells us that the value of A is less than 0, which means that there has to be a vertical reflection in the x-axis. A vertical reflection in the x-axis. Normally, the base graph of cosine is in the shape of a V. However, because of the vertical reflection, you will now have an upside down V. So the graph has to open downward. As well, because of the x plus pi over 3, that represents a horizontal translation equal to a negative pi over 3 units to the left. So if we look at the V-shaped parts of this graph, pi over 2 units to the left, pi over 3 units to the left, eliminates part C as a multiple choice answer because there is no reflection. There's no vertical reflection with that graph. You still have your your regular V-shaped graph. However, in part A, if you look at the section of the graph that's highlighted there, you have your upside down V, and notice that the graph was translated pi over 3 units to the left. So that corresponds with A as the multiple choice item. In example 4, we are asked to graph y equals a -2 times the sine of 2x minus pi over 2 minus 2. The first thing we need to do is to fix the equation as follows. It will then become y equals a -2 times the sine of, we remove 2 as a common factor, outside of x minus pi over 4. So now we are able to determine that we had a horizontal stretch factor of 1/2 and a horizontal translation of pi over 4 units to the right. Now we can go to the mapping rule. And the mapping rule that corresponds with this function. You take xy from the base graph of y equals the sine of x, and you will take 1/2 x plus pi over 4 and a -2y minus 2. So the key points that we will substitute into the mapping rule from the base graph of sine x will be 0, 0, and 0, 0 will get mapped onto pi over 4 and a -2. In order to sketch this graph, I recommend that we start off by graphing the sinusoidal axis. So the sinusoidal axis here passes through y equals a -2. So let's put that equation, or put that horizontal line in. Through y equals a -2. So now we can plot the first point on our new graph, which occurs at pi over 4 and -2. There's pi over 4 and -2. So we will go up in increments of pi over 4 on our x-axis. 2 pi over 4 is the same as pi over 2. There's 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4 is just 2 pi, 9 pi over 4, 10 pi over 4, 11 pi over 4, and 12 pi over 4 is just 3 pi. So let's substitute the next value in, and that will occur at pi over 2 and 1. Half of pi over 2 is pi over 4, plus pi over 4 is 2 pi over 4, or just pi over 2 radians, and negative 2 times 1 minus 2 is a negative 4. So we have pi over 2 and a negative 4. Notice that that point is 2 units below the sinusoidal axis, which tells us that we have an amplitude for this function equal to 2. The next point we will substitute in is at pi and 0. Half of pi is pi over 2, which is the same as 2 pi over 4, plus pi over 4 is 3 pi over 4 and negative 2. 3 pi over 4 and negative 2. And then you substitute in 3 pi over 2 and negative 1, and that will go to half of 3 pi over 2 is 3 pi over 4, plus pi over 4 is 4 pi over 4, or just pi, and a negative 2 times a negative 1 is a positive 2, minus 2 is 0. So at pi units, you have the y value will equal 0. And then the last point that we substitute in is 2 pi and 0. Half of 2 pi is pi, which is the same as 4 pi over 4, plus pi over 4 is 5 pi over 4, and the y value will equal a negative 2. So this represents one cycle of the new transformed graph. Let's just discuss a couple of things with this so far. You'll see that the value of d is equal to a negative 2. So the sinusoidal axis, which is the central line that passes through the graph, passes through y equals a negative 2. Notice also that the amplitude of this function is equal to the absolute value of a negative 2, which is 2. So a maximum point on the graph is 2 units above the sinusoidal axis, and a minimum value of this graph is 2 units below the sinusoidal axis. Normally, your sine graph is a sideways S that goes upward at the beginning. Because of the vertical reflection in the x-axis, the graph will go downward at the beginning. And as well, you have a horizontal stretch of a half, which means that the period of your new function is going to be half the regular period for sine. And notice here that the distance between a pi over 4 and 5 pi over 4 is 4 pi over 4 units, which equals pi. And that is the period of the new function. And as well, we have a horizontal translation of pi over 4 units to the right. Normally, the sine graph begins when x is equal to 0, and now it's beginning when x is equal to pi over 4 units. So that represents one full cycle of the new transformed graph. Given the fact that the period continues, we can draw another cycle of this graph. At 3 pi over 2, the y value will equal a negative 4, 7 pi over 4 and negative 2, 2 pi and 0, and 9 pi over 4 and negative 2. So this would represent another cycle of the transformed graph. And we could do the same thing in the negative direction. So at 0, 0 will be a point on the graph, as well as a negative pi over 4 and a negative 2. Then you would have a negative pi over 2 and a negative 4, and then a negative 3 pi over 4, and back to negative 2 again. And then at negative pi, we will be back at 0, and a negative 5 pi over 4, we're back to a negative 2. So this represents another cycle of the transform function. But the region that I want to highlight is the region between pi over 4 and 5 pi over 4. That represents the transformed section. So in this case then, we can now state what the vertical displacement is. The vertical displacement equals 2 units downward. That gives us that's, by the way, is the same as the vertical translation. And that also tells us that the sinusoidal axis passes through y equals a -2. The phase shift is the same as the horizontal translation, and that's equal to pi over 4 units to the right. We are also asked for the domain and the range of this function. The domain are all values of x belonging to the set of real numbers. And the range of this function, the minimum value occurs at -4. So we have -4 is less than or equal to y, which is less than or equal to 0, because 0 is the maximum value of this function. And the values of y belong to the set of real numbers. In example 5, we are asked to sketch the graph of the function 1/3 y is equal to the cosine of 1/2 times theta plus pi over 2 minus 1/3. In this example, we need to solve this equation for y, and in order to do so, we will multiply both sides of the equation by 1/3. Sorry, we will multiply both sides of the equation by 3 to get rid of the 1/3. So when you multiply 3 times 1/3 y, you just get y is equal to 3 multiplied by the cosine of the angle results in 3 cosine of 1/2 times theta plus pi over 2. And what's important here is that you also have to remember to multiply -1/3 by 3 to get -1. So now to begin this graph, recognize that d is equal to -1, which gives us the equation of our sinusoidal axis, which passes through y equals a -1. So I will begin by drawing in the sinusoidal axis. Through y equals a -1. Now we will set up a mapping rule to draw sketch the graph of the other points. So we will have xy will get mapped onto. The reciprocal of 1/2 is 2, so we have 2 theta minus pi over 2, and we will have 3y minus 1. The key points from the base graph of cosine, we begin with the point 0, 1. 2 times 0 minus pi over 2 is at -pi over 2, and 3 times 1 minus 1 is equal to 2. So we have a -pi over 2 and 2. That will give us the first point on the new transformed graph. Then we will go to pi over 2 and 0. 2 times pi over 2 is just pi, minus pi over 2 is pi over 2. And 3 times 0 minus 1, so we have the point pi over 2 and a -1. Then we will have the point pi and -1 from the base graph. 2 times pi is 2 pi, which is the same as 4 pi over 2, minus pi over 2 is 3 pi over 2, and 3 times a -1 minus 1 is a -4. So let's label this axis pi over 2, pi, 3 pi over 2, and -4. And then we will go to the point 3 pi over 2 and 0. 2 times 3 pi over 2 is just 3 pi, which is the same as 6 pi over 2 minus pi over 2 brings us to 5 pi over 2, and a negative 1. So this is 2 pi, which is the same as 4 pi over 2. Here's 5 pi over 2 and a negative 1. And then the last point that we will substitute in is 2 pi and 1. 2 times 2 pi is 4 pi, which is the same as 8 pi over 2 minus pi over 2 is 7 pi over 2 and 2. So you had 5 pi over 2, 6 pi over 2, 7 pi over 2, and 2. So this is a V-shaped graph that will represent one cycle of the transformed function. Notice that the distance between a negative pi over 2 and 7 pi over 2, that distance represents one full cycle, which is equal to 8 pi over 2, which is just 4 pi. And that will give us the period of the transformed function. We are asked to draw 2 cycles of this graph, so I will extend the graph towards the left, here at negative pi and a negative 3 pi over 2. So that point will be at negative 3 pi over 2 and negative 1, negative 2 pi, a negative 5 pi over 2, and that graph, that y value will be at negative 4, negative 3 pi, negative 7 pi over 2, will be back at negative 1, negative 4 pi, and then we need another point over here. I will just fit it in if I could. That's at negative 9 pi over 2, and that will be up at a positive 2. So here we have another cycle of this transform function. And now we can state the amplitude of the function. We can look at the amplitude as being the distance between the sinusoidal axis. I'll just highlight that in another color. So you can look at the distance between the sinusoidal axis and a minimum or a maximum point on your graph, and that will give you the amplitude of the function. So we can say here that the amplitude is equal to 3. And the amplitude is also determined by the value of A. You have the value of A is equal to 3, so that tells us that the amplitude of the function is equal to 3. You could have also used the formula to determine the amplitude by taking the maximum value of the function and subtracting the minimum value and dividing it by 2. The maximum value is 2, minus a negative 4 all over 2 results in 6 over 2, which is still equal to 3. So you can use the distance between the sinusoidal axis and a maximum point on the graph, or the distance between the sinusoidal axis and a minimum point on the graph to get the amplitude. Or you can use the formula. It's entirely up to you. Or you can recognize even that the absolute value of A is equal to the amplitude. So the amplitude is equal to the absolute value of A of the function. Then we are also asked to talk about the vertical displacement. So the vertical displacement here is the same as the vertical translation. In this case, it is equal to a negative 1, meaning that we move 1 unit downward as the vertical displacement. And that also gives us the equation for our sinusoidal axis. The phase shift in this case, the phase shift is the same as the horizontal translation. And in this case, you have a horizontal translation equal to a negative pi over 2, meaning that the base graph is shifted pi over 2 units to the left. And then we are also asked for the range of this function. That would be all values of y such that -4 is less than or equal to y, which is less than or equal to 2, and y belongs to the set of real numbers. The minimum value of the function is at -4. The maximum value of the function is at 2. So that's where the range comes from. The range is dependent upon the location of the sinusoidal axis as well as the amplitude of the function, 3 units above and 3 units below the sinusoidal axis. You can determine the amplitude, the period, the phase shift, and vertical displacement of sinusoidal functions when the equation of the function is given in either of those forms. What's important to remember is that if a is less than 0, it results in a vertical reflection in the x-axis. In the case of the amplitude of the function is equal to the absolute value of a, and that also corresponds with the vertical stretch. The value of b, if b is less than 0, that results in a horizontal reflection in the y-axis, and we also have a horizontal stretch factor which equals the reciprocal. So it would be 1 over the absolute value of b, represents the horizontal stretch. And the horizontal stretch affects the period of the function. The period is equal to the horizontal stretch multiplied by 2 pi, or it can be equal to the horizontal stretch multiplied by 360 degrees if you are using degree measure. The value of c, if c is greater than 0, you have a horizontal translation to the right, which represents the phase shift. If c is less than 0, you have a horizontal translation to the left. And in either case, this represents the phase shift of the base graph of the function. And then similarly, if you have d to be greater than 0, you have a vertical translation upward. If d is less than 0, you have a vertical translation downward. And this affects the vertical displacement of your function. That will also give you the equation of your sinusoidal axis, which will pass through y equals d. So that's what each of the parameters a, b, c, and d represent. Thank you for your time and attention. If you have any questions, please pose them in the question forum and we will be happy to answer them for you. Thank you.